For most of human history, governments have made big decisions with a familiar mix of tools: memory, instinct, ideology, and a little bit of luck. Leaders looked backward at history and tried to guess what would happen next. But we're moving into something different. In the intelligence economy, the countries that win won't just be the ones with the biggest budgets or the most natural resources. More and more, the advantage goes to the nations that can run the best what-if games of the future and trust those games enough to act. Today we're talking about simulation intelligence. It's the capability to model the future, at least, to model plausible futures, so governments can test choices before they make them, watch risks form before they explode, and respond faster than competitors. Welcome back to the B.I channel, where data meets decisions. I'm your host, Soren Hale, and joining me is a strategist and the founder of the B.I channel, Nakel Nakima. We're going to dig into how simulation engines are reshaping national strategy, crisis response, and even diplomacy. Nakel, welcome back.
Always good to be here, Soren. And I'm glad we're doing this one, because simulation intelligence feels like it's quietly becoming one of the biggest forces in governance. It's not always in headlines, but it's already changing how serious decisions get made.
Let's start with definitions, because the phrase can sound a little sci-fi. When you say simulation intelligence, what do you mean in plain terms?
In plain terms, it's the ability to build a working digital model of real systems like an economy, a supply chain network, a city, or even social behavior, and then use that model to test policies and shocks before you experience them in the real world. Think of it like a digital twin of a nation's key systems. You feed it data, you encode relationships, you add constraints like capacity and budgets, and then you run scenarios.
So basically, a policy flight simulator.
Exactly. It's like training a pilot. You don't want the first time you deal with engine failure to be at 30,000 feet with passengers on board. In the same way, you don't want the first time you test a major interest rate shift, a fertilizer shortage, or a port shutdown to be on a live population and a live economy.
Give me examples of the kinds of questions a simulation engine is meant to answer, because I think people imagine a crystal ball, but it's more structure than that.
Right, it's not prophecy. It's disciplined scenario testing. A government can ask things like, if we raise interest rates by a point, what happens to inflation, employment, and household debt over the next 6 quarters? Or, if a major port is blocked for 3 weeks, which industries run out of inputs first? How fast do prices spike? And what are the fastest alternative routes? Or, if a drought hits our agricultural region, what happens to food prices, rural migration patterns, water consumption, power demand, and political sentiment?
And that's the thing. It's never just one outcome. The drought isn't only a drought. It becomes a logistics problem, a healthcare problem, a public opinion problem, sometimes even a security problem.
Exactly. Simulation intelligence is about connections. It forces leaders to see the system as a system. It turns decision-making from isolated policy moves into something closer to systems engineering.
Why is this suddenly essential? Governments have always used models. Central banks have models. Defense departments have war games. What's changed?
3 big shifts. First, global volatility. The world is more tightly linked than ever. Energy, shipping, finance, information, migration. So shocks travel faster. One disruption can cascade across continents in days. Second, real-time data. We now collect enormous volumes of data from transportation systems, payments, satellites, sensors, telecom networks, hospitals, utilities. You can see what's happening almost as it happens, if you have the infrastructure to integrate it. Third, AI acceleration. With modern AI, you can generate and evaluate millions of scenarios quickly. Not just one forecast, but a range. Best case, worst case, and the messy middle where real life usually lives.
So it becomes less of a luxury and more like a survival capability.
That's the right framing. It's survival and its advantage. If 2 countries face the same shock, the one that can simulate the cascade effects and deploy the right response faster will take less damage, and sometimes can even benefit.
And that advantage isn't just we reacted faster. It's that you can choose policies more confidently because you've already pressure tested them in the simulator.
Exactly. You're reducing uncertainty. You're also reducing political risk because you can show your homework. at least when governance is transparent.
Let's break this down. If a nation is building simulation intelligence, what kinds of engines are we talking about? Because simulation is a big umbrella.
I like to simplify it into 4 categories. Not because reality is only 4 things, but because the categories help you see how the capability gets built.
All right, category 1.
Economic simulation engines. These are systems that model the economy's moving parts. Inflation dynamics, employment and wages, credit conditions, trade flows, consumer behavior, business investment, and market shocks. They help governments and central banks ask, what happens if we change taxes, expand subsidies, adjust interest rates, or impose tariffs? And importantly, what happens not just nationally, but across regions and income groups?
So it's not only GDP, it's distribution, second-order effects, and timing.
Exactly. A policy might look great in the aggregate but brutal in a specific sector. Simulation makes that visible earlier.
Category 2.
Supply chain simulation engines. This is the logistics nervous system. Ports, shipping lanes, warehouses, rail networks, truck routes, manufacturing clusters, and critical inputs like chips, fuel, fertilizer, medical supplies. A government can simulate disruption. What if a shipping lane is restricted? What if a refinery goes offline? What if a key supplier country imposes export controls? Then you can pre-plan stockpiles, alternates, and priority allocations.
I'm thinking about how often we hear the phrase resilience now. This is resilience with math and infrastructure behind it.
Yes, resilience stops being a slogan and becomes a measurable operational plan.
Category 3.
Climate and environmental simulation engines. These model droughts, floods, heat waves, wildfire risk, sea level impacts, water systems, and energy demand. Because climate isn't just weather, it's a force multiplier across infrastructure. For example, if a city expects more extreme heat days, the simulation can estimate power use spikes, transformer stress, hospital load, public transit failures, and which neighborhoods are at greatest risk.
So you can decide what to build, where to build it, and what to reinforce first.
Exactly. It supports climate adaptation with prioritization, not guesswork.
And category 4, the one that always makes people pause.
Societal simulation engines. This is where it becomes more complex and more sensitive. These systems try to model population behavior, mobility patterns, healthcare demand, education outcomes, labor transitions, public sentiment, and how groups respond to policy changes. It's not about controlling society. In the best form, it's about anticipating unintended consequences. If you change a subsidy or impose a new rule, how do people adapt? Do they change purchasing patterns? Do they move? Does informal economic activity rise? Do you get political backlash?
This is a place where simulation can sound like social engineering.
And that's why governance and ethics matter. Societal simulation can be used responsibly, to improve services and reduce harm, or irresponsibly, to manipulate. The capabilities are the same. The intent and oversight are what make the difference.
Before we go into risks, I want to talk about where this is happening. People might assume only superpowers can do this, but you've been tracking different regions. Who's leading and in what way?
Leadership looks different depending on the domain. In parts of APAC, you see extremely advanced city-scale digital twins, real-time models of traffic, public transit, utilities, energy consumption, and commercial activity, built to optimize day-to-day operations as well as emergency response.
So the city becomes the lab?
Exactly. And city scale is often where it starts because you can measure outcomes faster.
What about Europe?
Europe has been strong in climate modeling and also in the norms around responsible use, ethics frameworks, governance principles, privacy expectations. Not perfect, but there's a serious effort to define what should and shouldn't be simulated, which data should and shouldn't be used, and how transparent systems must be.
North America.
The United States has long been advanced in defense simulations and large-scale economic modeling. There's deep capability in both government and the private sector, plus strong compute capacity. You also see industry-driven simulation, especially around logistics, energy markets, and financial stress testing.
What about regions people don't typically associate with advanced simulation?
LATAM is a great example of pragmatic simulation. In several places, Simulation is being used to stabilize agriculture logistics, plan for climate variability, and manage supply chain fragility. It's not always flashy, but it's targeted at urgent economic needs.
And Africa?
Africa has a big opportunity to leapfrog with mobile-first and cloud-first simulation platforms, especially for urban planning, infrastructure rollout, and resource management. When you build new cities or expand fast-growing ones, simulation is incredibly valuable because you can avoid expensive mistakes.
That's important. The goal isn't to copy one model of simulation intelligence. It's to build the capability in a way that fits the region's constraints and objectives.
Exactly. And capability design matters. Some nations will prioritize food security simulations. Others prioritize energy grid stability. Others prioritize coastal resilience. The best engine is the one aligned to your real risks.
All right, let's turn to the dark side, because every powerful tool has one. What are the major risks of simulation intelligence?
I usually group them into 4. First is over-reliance on the model. People start treating the simulation like reality instead of a simplified representation. And then they stop listening to ground truth, local knowledge, or signals that the system is outside its training range.
So the map becomes mistaken for the territory.
Exactly. Second is bias. If your data is incomplete or skewed, or if your assumptions reflect only one group's experience, your simulation will systematically mispredict outcomes, often at the expense of vulnerable communities.
And the scary part is that biased output can look scientific, so it gains authority.
Right. Third is opacity. If the algorithms are black boxes and nobody can audit them, you can end up with major national policy being shaped by systems that even decision-makers can't fully explain.
And the fourth?
Simulation warfare. This is the idea that nations or powerful actors can use simulations not just defensively to prepare but offensively to manipulate. For example, influencing expectations in markets, exploiting supply chain vulnerabilities, or using predictive advantage to trigger cascading consequences in another country's economy.
Simulation warfare is a chilling concept because it doesn't require missiles. It can be quiet. It can look like market forces.
Exactly. If you can anticipate reactions better than the other side, you can nudge a system. And in a globally connected world, small nudges can become big waves.
So how do you build simulation intelligence responsibly and effectively? If a policymaker is listening and thinking, we're behind, what's the roadmap?
First, you need solid national data foundations. People call them data lakes, but the point is simpler. Integrate key datasets with high quality, good governance, and secure access. Without reliable data, simulation is theater. Second, invest in simulation platforms, tools, and compute, yes, but also the modeling expertise. You need economists, engineers, climate scientists, data scientists, and domain experts working together. Simulation isn't just an IT project.
Right. Too many initiatives die because they're framed as software procurement instead of capability building.
Exactly. Third, create cross-industry data partnerships. Governments don't own all the data that matters. Logistics companies, telecoms, financial institutions, energy utilities, these are key pieces of the system. Partnerships with strict privacy protections can unlock realism. Fourth, train leaders in simulation literacy. Ministers, mayors, and agency heads need to know what a model can and can't do, how to interpret uncertainty bands, and how to compare scenarios without falling for a single precise number.
So the output isn't the answer, it's the range. And leaders have to be fluent in that.
Exactly. And fifth, establish ethical oversight. Clear rules on data use, transparency, accountability, auditability, and human rights. If the simulation is influencing national policy, it must be governable.
And that line you said earlier keeps ringing in my ears. Simulation intelligence isn't a tool. It's a national capability.
Yes, tools can be bought. Capabilities have to be built. Skills, institutions, standards, culture, and trust.
Let's bring this home. If you had to summarize what simulation intelligence means for the future of national power, what would you say?
I'd say power shifts toward whoever can anticipate systems. Not perfectly, nobody can, but better than others. The future belongs to nations that can test decisions before they deploy them in the real world. and that can see risks forming early enough to act with precision.
Simulation intelligence is the next frontier of national strategy. The countries that can model the future will have a better chance of shaping it. And the ones that can't, well, they may find themselves reacting to events that others already rehearsed. Nakel, thanks for coming back.
Always a pleasure, Soren.
And thanks for listening to the BI channel, where data meets decisions.